Chapter 8, Understanding Drug Labels. So on drug labels, we have all this information on it, plus sometimes we have information in the package, plus the pharmacist gives you more information as well. On a drug label, we have to determine what is the name of the drug. So sometimes the doctor or the nurse practitioner will prescribe a drug in a generic form or in the brand name, and then you go to the supply closet or the pharmacist and they give you the opposites. You got to know which goes with which. Also, got to make sure that sometimes we have look-alike, sound-alike names. You got to make sure just to double check. So chapter 8 is going to be a reading chapter for you. I'm just going to skim over it just to make sure that you do read it for future health classes. So things to look at on the drug label, again, is the brand name. The brand name is usually most prominent on it. And then you may have the generic name on it, and it is as a must on all drug labels is what I found in the textbook. But there may be occasions when only it has brand name on it. It might not have both. And it is very important that the person that's administering the drug cross-checks the medications to prevent errors. Dosage strength. What is a dosage strength, guys? Dosage strength is the amount versus the strength. So basically what it is if you go get a bottle of Tylenol and it says 250 milligrams and then it says 100 tablets, then that means for every one tablet is 250 milligrams. That is dosage strength. Dosage is telling me the amount or the volume. The strength is telling me the milligrams or milliliters per unit, per tablet, per capsule, so on. Form of the drug is it a solid, a liquid, is it powder? So the form tells you the type. Will you be drinking it? Will you be swallowing it? Will it be an IV? So on. Amount is going to be something you can count. So tablets and capsules, 1, 2, 3, 4, that's an amount. A volume would be if you were giving cough syrup, it's got liquid, right? So that's a volume. IVs or volumes. Expiration date is very, very important because if it exceeds an expiration date, it's time to discontinue, right? But I do also know the further along you get in the health programs, you'll notice that if you have injections, they may have single dosage, multiple dosage, whatever it may be. Whenever you use it, you have to label it. It may state once you reconstitute it, expire in 7 days. So there's an expiration date. It's very important that you follow the guidelines of whatever you're working with and stay on top of the expiration date. And again, the single and multiple dosage that goes with injections. So some like a diabetic may get a bottle that's a single dose, and it may leave a little bit left because they can't take it all because it's not all prescribed to them, so they have to discard it. But then they may get a bottle that has multiple dosage in it, so they have to write on there when they mixed it, when they took it. Of course, nowadays we got the new up-to-date medication, so I don't believe it is as complicated. But again, this is math class, not the health program. And the printer is going to work in the middle of my thing. All right, thank you. Now, unpause and move on. So control number, lot number is usually found on the label, which I will go over those here in just a little bit. Controlled substance schedule, basically it tells you how addictive the drug is. So it's not on all labels. and it doesn't go to all medications. But if it's a level 1, then it's the most abusive, most addictive. A level 5 is the less addictive, and the numbers go from 1 to 5. And it's written as, let me get my pen out. It's written as, you will see it written like C1, where inside the C is the 1. Let me erase this stuff. And it's written in Roman numerals. That is something good to know. Roman numerals. C1, C2, C3, C4, C5. And again, C1 is the most addictive. It's said that it's the one to be abused the most. National Drug Code, what is that? That's the code that's on the label somewhere. And you can take that code and type in NDC and then put in that code in the computer, and it'll pull up that drug for you. So that's very, very important too. It saves a lot of time on the pharmacist in looking up. Barcode is where they're going to scan it. And then manufacturer, of course, is who made it. So let's go to the next part. So checking labels. When we check labels, a really, really good important part is the 6 rights. And what are the 6 rights? They're the right patient, right drug, right amount, right route, right time and frequency. And guys, I noticed in the textbook, sometimes it says frequency with this, sometimes it just says time. So just be careful. Make sure time and frequency goes together, which makes sense. Right documentation. So the 6 rights. Also, we have the medication order on the MAR. So you want to definitely take the medication that's you got from the supply closet, the pharmacy, or whoever. You're going to compare it to the MAR. You want to make sure you're giving the right person the right drug, the right amount at the right time. Before preparing the medication, always double check it. After preparing the medication and before administering, you still want to double check it because this could cost someone their life. Label alerts. So warnings on the label or printed on the packaging or added by the pharmacy before dispensing. So we're going to look for those warnings. Check for special storage alerts. Some may say keep in the dark, some may say refrigerate, some may say room temperature. Just make sure and read those directions. Directions may instruct the healthcare professional to shake well before using as a reminder to remix the components. So very, very important to read all the instructions on it before you administer a drug. So we have an example I'd like to work with y'all. Here we go, and let's talk about it right quick. So looking at this label here, I notice that the question here wants to know the first thing, trade name and generic name. Now, I am working with odor labels, so some of them may only have one or the other. Some may have both. I do know that whenever we see this, if this is not something you worked with that often, you need to do research, especially in this class. If I give you a project, you'll have to double check. So amoxicillin, we know it's a penicillin. And my research showed that this here is an actual trade name, but what do I know about it? I know that usually USPS, according to the textbook, states that it's a generic. So on this particular question, we are only a math class. We are not the nursing program or the health program. So on this particular question, I won't be as strict about it other than what's the name of this drug? Well, it's a amoxicillin. If I was to give you a doctor's order to give the patient some penicillin and the pharmacy gave you amoxicillin, you need to know that this was the penicillin, is just amoxicillin. I also did a little bit of research and I noticed a generic name for amoxicillin. The generic name for this is AMOXIL. And that was based upon the research I did. But in this class here, I'm not going to ask you as far as that. What I need to know is, do you recognize what's the name of the drug? And if you were given an order, so this is the supply, and if you were given an order for the pharmacist that said penicillin, to give so much penicillin to this patient, you would know that out of all the labels given to you, that this would be the one that you would give. Dosage strength. So what does it tell me about the dosage strength? This here, 400 milligrams. So that's the strength per 5 milliliters. That's the dosage. National Drug Code. That is this here. So I would write that number here, 0781-6157-52. And then the route. Well, we'll have to go up and read about it. And what does it say about the route? Oh, looky here. It says oral suspension. It's oral. Now, is it an amount or volume? This is talking about the whole package, not per serving, right? The whole package. Well, it's in volume, right? Because it's milliliters. So I would circle volume, and the whole total is 50 milliliters. Storage. Well, we'd have to read this information right here. And if you could find where it says to store, which I see it right here, store and dry, right here. Let me highlight that specific spot. If I did that and then came right here and did this, I would be happy if I gave you a written assignment. If it's on the, if you have to type it, it'd be different, but recognizing it. Here's the expiration date. Of course, there's not one. This is an O label I work with. Here's a lot number that I work with. These are things you need to know for the program. For here, why is it important to be able to recognize what each part is because I'll give you a label. I'll give you a doctor's order. I'll say that you are to administer so many tablet, or the doctor says give so many milligrams of this particular drug, and you got a generic versus the trade, and what you have on hand may change the actual outcome. So you need to know that. So this next one is going to be the example of what I was talking about. So the doctor orders 650 milligrams every 6 hours stat. That means immediately, right? What will the nurse administer? Well, if the doctor orders 650 milligrams, and I'm going to say it should have said penicillin. Okay. And you go to the pharmacy and they give you this right here. They give you amoxicillin, 450 milligrams per 5 milliliters. So now we got to figure out how much to give. So we're going to take our order, which is 650 milligrams. And what do we got in our dosage strength of the supply? Well, it is milligrams per milliliter. So milligrams and milligrams reduce. We don't have to do a needed conversion, right? So I have my desired on hand, right? You see that? Times my quantity. And what is my quantity again? 5 milliliters. This is why I wanted you to understand amount and volume, because that's a quantity, right? So now I got this option. I got 650 milligrams times 5 milliliters over the 400 milligrams. And what happens to the milligrams? Well, they reduce, right? Leaves me with 1 in there. 1 times 650 is 650, 1 times 400. And now we're going to just multiply straight across and then divide. So 650 times 5 divided by 400 gives us a decimal of 8.125 milliliters. So we are talking about a volume. And usually on a volume, we're going to round this to the nearest whole number. Make sure and read here. I didn't give you instructions for it, but I could have asked you to round to the nearest hundreds, right? That would have been this. Or I could have asked you to round to the nearest whole number, which is this. Or I could have said round to the nearest tenths. So just make sure and read what's asking of you, okay? Read the directions. By a certain point, you should know it. So definitely go back to my when to round instructions. It's in Canvas. Go back to that if you haven't already checked it out. And if you're confused, in this case here, since it is math class, I would ask you to round to the nearest hundreds because it's not an IV, it's an oral dosage. However, in real life, there's a chance you probably will round to the nearest whole number because that's easier to measure, right? 8 milliliters is easier to measure. Let's do one more example. So this next example, we're going to look at it again, and we're going to determine what is the name of this drug. And again, I am not as hard on you about if it's a generic or name brand, and more to say that you are able to tell that you can determine what the doctor ordered versus what is given to you at the pharmacy. You do need to know this, and this is something you need to know before you get in the program. The more you learn here, the easier it is in the program. So I did my research and I found some generic names for this, and there was multiple generic names. So I'm not 100% sure on these because I did not go to the nursing or the health or medical field, but this was my research that I found. The generic name was Toamapaz. Okay, I'm not even going to try to pronounce that. So I would put that here. Another way is used to, on the odor labels, it used to have a little bitty R, a circle with a little R in it. Used to tell you that it was a brand name, a trade name. Also something I didn't show you a while ago, here is the manufacturer's name. Right here, here we go. And it's distributed by this company here. So that's something to need to know as well later on. Dosage strength. All right. What are we working with? We're working with capsules. I can go ahead and answer this. I can answer F. It's amount, right? Because I can count. And we know it's 1,000 capsules. All right. So what is the dosage strength? Well, we know that it's 25 milligrams per capsule. If you spell it out, you would, excuse me, let me backtrack. If you write it in its abbreviated form, do not put a period and do not put an S on it, just abbreviate it. The national drug code is right here. Okay, and then the route. So the route here, if you notice, it's a capsule. It's going to be oral unless it says any otherwise. storage information. Here you go. I found the storage right here. I'm going to draw an arrow. The last question on here says, show all your work. Okay, so the doctor ordered 75 milligrams BID twice a day. For 7 days. What is the amount of the capsules in a single dose? Okay, so if the dosage strength is 25 milligrams per cap, milligrams and milligrams reduce, so we don't have to add a needed conversion. So the milligrams reduce, and then how many times will 25 go into 75? 3 times. So it's 3 capsules. Now it says, what is the amount in 7 days? So if they're going to take 3 capsules per sitting, and we're going to do it BID, which is twice, times 7 days. So that means we got 3 times 2 times 7. 3 times 2 is 6, times 7 is 42 capsule in 7 days. So that is understanding drug labels and why it's important for mathematics.